Welcome back, Focus Learners, to another explainer. Today, we're diving straight into a foundational piece of the OSI Model's transport layer. We're talking about the User Datagram Protocol, or as pretty much everyone calls it, UDP. Now, this is a massive cornerstone of modern networking. But here's the kicker. At first glance, its design appears to be fundamentally flawed.
Which brings us to a massive central paradox. Why use an unreliable internet protocol? Just think about it for a second. We rely on the internet for absolutely everything, right? Yet, a huge chunk of that daily traffic uses a protocol that actively avoids guaranteeing data delivery. We're talking about a system built to drop packets, mix up the order, and honestly, just not care if your data arrives safely at all. So why on earth were we using it?
Okay, let's dive into this. Section 1, the 5 core characteristics. Let's look under the hood of UDP. First up, UDP is what we call a connectionless protocol. So what does that actually mean in practice? Well, it basically means it completely skips the digital handshake. Before it sends your data, it doesn't bother asking the receiving device if it's ready, or, even if it's online, it just starts firing off packets to the destination. It's exactly like dropping a letter in the mail without ever checking if the recipient actually lives at that address.
Next, we have a rather blunt definition. It's unreliable. Now, in the networking world, calling something unreliable sounds like a catastrophic flaw, right? But here's the thing. This behavior is entirely intentional. UDP does not guarantee the delivery of your data packets, and it literally doesn't lift a finger to ensure they arrive in the correct order. It is quite literally built to not care if the data gets there perfectly or in sequence.
And that brilliantly highlights our third characteristic. If we compare UDP directly to its famous counterpart, TCP, the differences are night and day. You see, TCP has these careful mechanisms to manage the rate of data transmission so it doesn't overwhelm the receiver. But UDP, absolutely no flow control whatsoever. It drops those management mechanisms entirely just to send data at the maximum speed possible. It really only has one gear, and that gear is maximum velocity.
Moving right along to our fourth characteristic, we have no congestion control. Not only does UDP blast data at top speed, but it also completely ignores the surrounding network environment. If there's a massive digital traffic jam ahead, UDP will not adjust its transmission rate to help clear things up. It just keeps sending. Ironically, this means UDP traffic can actually contribute to network congestion simply because it stubbornly refuses to slow down. Finally, the fifth characteristic is really what ties this all together, the lightweight header. Because UDP isn't carrying all that extra baggage required for connection handshakes, packet ordering, flow control, or congestion management, its data header is vastly simpler than TCP's. And this lightweight design is exactly what makes UDP so incredibly fast. It strips away all that reliability overhead to achieve pure, raw efficiency.
Which brings us to Section 2, Real-Time Entertainment, and why your daily apps need speed.
Just think about the apps you use every day. VoIP for your voice calls, video streaming, online gaming, real-time broadcasting. For these applications, speed is absolutely everything. If a few data packets get lost in transit, you might see a slight glitch or a tiny drop in video quality. And honestly, that's totally acceptable. But if the network had to stop and resend those lost packets just to make sure everything was perfect, you'd experience lag. And in real-time entertainment, lag is a complete deal breaker. So, UDP's lower latency and real-time transmission capabilities are exactly what make these seamless experiences possible.
Moving on to Section 3, Essential Network Management, and the back-end tools running on UDP. Now, what's really interesting here is how much of our standard internet infrastructure defaults to UDP, simply because of that lower overhead. Take DNS, for example. Every single time you type in a web address, a DNS query goes out over UDP to quickly find the IP address. Then there's DHCP, which dynamically hands out IP addresses to devices on your network. We've also got SNMP for network management messages, TFTP for booting devices over network, and NTP, which is silently synchronizing the clocks of all your network devices. All of these essential invisible background operations, they default to UDP to keep the internet running smoothly and, most importantly, quickly. This brings us to a perfect summary quote directly from the source material. It says, UDP is chosen for applications where speed and efficiency are more critical than data integrity and reliability. And that right there completely resolves our initial paradox. We actively choose an unreliable protocol because in so many everyday scenarios, having the data arrive right this very second is just far more important than making sure every single byte is absolutely perfect.
So, I want to leave you with this final thought and a bit of a challenge. How much of your daily internet diet actually relies on this speedy protocol?
From the exact moment your device syncs its clock in the morning, to the DNS queries loading up your favorite news sites, all the way to the video calls and online gaming you do at night, it is all running on the fast, chaotic, connectionless magic of UDP. Thanks so much for joining me on this explainer, and remember to always keep questioning how your digital world actually works.